Alright, so today we're looking at lesson 7. We're going to look at linear motion and average velocity, and then we're going to look at average acceleration. So hopefully after this lesson you'll understand linear motion and average velocity as well as average acceleration. So the parts of physics in which we study the relations between force, matter, and motion is called mechanics. The parts of mechanics in which we study motion without considering the forces that cause the masses to move is called the kinematics. So that's just a little bit of terminology for you. In kinematics, it is convenient to use an imaginary object called a particle, and it's just a small object of negligible mass, and it does not change shape, and it does not rotate. So it's just basically like a little dot. We're going to indicate direction that is parallel to the x-axis by using a plus sign for displacement of velocity or acceleration in the positive x direction, and negative sign to indicate displacement or velocity or acceleration in the negative x direction. So if you were going this way, well, if you're going this way, that's going to be a plus, and if you're going this way, that's going to be a minus, just like on your x-y axis. This is the positive numbers, and these are the negative numbers. So your average velocity is just the change in position or displacement divided by change in time. So we talked about that a couple of lessons ago. We did not talk about this formula. So we're going to be using this formula today. So V sub AV is just the average velocity. X2 is where you end, it's your final coordinate, and X1 is your initial, where you started. T2 is your final time, and T1 is your initial time. So we're going to be using that formula for this example. So I'm going to go ahead and write it out. Average velocity, X2 minus X1 over T2 minus T1. So it says a particle moved from an x-coordinate of 20 to an x-coordinate of 12 in 4 seconds. What was its average velocity? So where did it end? It ended at 12, and it started at 20. And then it says in 4 seconds. So T2 is 4, and T1 is 0. So 12 minus 20 is negative 8. 4 minus 0 is 4. So if you divide, you get negative 2. Now we need to go back. This has 2 sig figs, this has 2 sig figs, and this has 2 sig figs. So our answer should have 2. So negative 2.0, and then units on velocity. Distance was centimeters per time, which was in seconds. So that would be your answer there. Okay. Looking at another one. At 12 seconds, the plane was at an altitude of 500 meters. By 30 seconds, it had climbed to 1257. At 80, it had dropped to 600. And then they have an A, B, and C. So let's start with A. What was the average velocity between 12 and 30 seconds? So 12 and 30, those are our times. So we're going to do 30 minus 12. Because you always do T2 minus T1. Now the position at 30 was 1,257, and the position at 12 was 500. So if you divide, well, 7 minus 500 is 757, and 30 minus 12 is 18. And so I divide and get 42.05 repeating. And everywhere you look, well, this one has 2 sig figs, 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 that one has 2 sig figs, but 500 only has 1 sig fig. So we use the 500, so we have to only have 1. So that would be 40. And then our units are meters per second. Okay? So that would be for A. For part B, what was the average velocity of the plane between 30 and 80 seconds? So we're going to do 80 minus 30 because it's T2 minus T1. And then at 80 seconds we were at 600. And then we're going to subtract 1257. And so if you subtract those, you get negative 13.14. Now, the four numbers that we used this time all had at least 2 sig figs. So our answer is going to have 2 sig figs. So negative 13 meters per second. Okay? So now we're going to look at the average between 12 and 80. So 80 is our T2, 12 was our T1. So at 80 seconds we were at 600, and at 12 seconds we were at 500. So if you subtract, you're going to get 100 over 68. And when you divide that, you get 1.47. And 500 again only had 1 sig fig, so our final answer can only have 1 significant figure. So 1 meter per second. And so that would be your answer for the third part. So that's how you can do average velocity. Now we're going to look at average acceleration. The average acceleration of an object during a time period is the change in the velocity divided by the length of the time. And so this formula looks really similar to the average velocity acceleration. So this is average acceleration. You start with your final velocity minus your initial velocity, and then final time minus initial time. So it looks very, very similar to the previous formula. So we're going to do an example. An object moving in the positive x direction went from a velocity of 100 to 40 in 4 hours. What was the average acceleration? So we're going to do v2 minus v1 over t2 minus t1. So we started at 100 and we ended at 40. So our final velocity is 40 and our initial was 100. And the change in time was 4. So t2 minus t1 is 4. So if you subtract, you get negative 60 over 4, and divide, you get negative 15. And so we have 2 significant digits, we have 3, and we have 2. So we have to have 2 in our final answer. So negative 15 has 2 significant digits, and then kilometers per hour squared would be your units for your acceleration. So that's how you do average acceleration. It's not terribly difficult for either one of those. You just need to know basically the formula. All right, so your homework is 1 through 20, so make sure that y'all do those tonight so we can go over any questions that you have tomorrow.